Hi, all. Good morning. Happy Thursday to all of you. We'll wait for a minute or two for more people to join and we'll begin shortly. Good morning. I'm Smitha Mave. I lead the Security Intelligence Platform engineering team in Google. Today, we are going to talk about the future of AI in cybersecurity. Let me start with the story. When I was a child, I enjoyed watching science fiction. I used to watch a lot of science fiction, thrillers, and so on. So it used to fascinate me, the possibility of technologies. And when I was a child, obviously, there weren't many of the technologies which are present right now were there, like the video conferencing and other technology were very fascinating because they didn't exist at that time. So later, I did see the whole evolution of technology and it becoming a reality, and it has become my day-to-day reality. Similarly, when the movies show hackers taking control of a country or a city, or sometimes if it's an alien attack, even probably the entire planet, I used to wonder, is that a possibility? It's just a science fiction, probably it's not possible. But then when I started my career, I started working in security domain. I started as a software engineer, software developer, started working on developing antivirus software, malware detection software, identity access management, and so on. And I did see uh, a lot of these malicious actors, uh, a lot of threats, vulnerabilities, virus creating havoc into the system. But a significant event happened in 2010. Something called Stuxnet happened. So that led to the coining of the word APT, Advanced Persistent Threat. It was a very interesting topic. There was a malware which seemed benign, which actually started spreading in a remote in different parts of the world. It started in some remote countries. I didn't look that harmful. But eventually, with the combination of social engineering and insider attack, so this actually attacked the Iran's nuclear reactor. So somebody using a USB stick copied this malware into a isolated system which was not connected to the network, and it had a code which looked for if there was a Siemens PLC 7 controller running. That means that's the one which actually controls the nuclear reactors. So if that system, that component exists, then it gave the data control away to the attacker. What was mind boggling was the amount of research time and the planning that was taken to make this attack happen. It's believed that the planning for this started in way back in 2005. So the attack happened in 2010. So they spent 5 years of the time. So again, allegedly, this was like foreign governments were behind this, but nothing has been proven yet. So it was the effort or the time and the planning and the size of the operation was larger than a large complex software system. So in 5 years we deliver really great software systems, and probably more than that, right? So that's when the world took notice. Security professionals took notice, and then it dawned to us that it's not a science fiction anymore. It's a reality. The technology, as it could be used for benefits, as we have been seeing a lot of advantages, and how technology has made our life easier. It could also be used for doing malicious things. So, with that as a note, cybercrime is a multi-billion enterprise. So, this is a report from FBI's Internet Crime Complaint Center. So in US alone, in last 5 years, the total number of complaints on the losses, cyber attacks, the financial losses, the complaints were around 3.7 million, and the amount of money that was lost is expected to be 37.4 billion. Again, a lot of these are underreported. We believe that it might be much larger. So we are not talking about a million or a billion. We are talking about multi-billion. Now let's come to the other side of the picture. So we have malicious actors. We have a cybercrime being a multi-billion crime industry. Uh, what does a day in a life of a cybersecurity professional look like? Uh, it could be one individual. It could be a combination of multiple individuals together. A cyber security team needs to take care of multiple things. They need to look at multiple tools and look at the alerts, and uh, keep themselves up to date on what are the existing threats, and they need to do penetration testing, risk analysis, policy updation, user education, disaster management, and if there is an incident, then incident management as well. So also some amount of proactive uh, threat detection and analysis and so on. So what we are trying to say is that the current challenges in cybersecurity, at one hand we have sophisticated malicious actors spending a lot of time, effort, money in developing technically sophisticated attacks. On the other side, we have massive amount of data and large attack surfaces. The number of devices, number of connections that happen, number of internet interactions that happen, and the data that we generate on a given day is huge. Is billions and billions of records, and multiple terabytes. So on the other side, we have shortage of skilled professionals, security professionals, because the amount of work has increased, and it has been traditionally painstakingly time consuming. There's a lot of effort involved in analyzing, in doing all the activities we mentioned earlier, and uh, that's the other real challenge that exists in the security industry now. Now, with this as a premise, with this as a current scenario, how does AI help in modern security challenges? So I consider the users of AI in three categories, especially in the security industry. One is a large organization who have a large IT and security team, who have the skill set and the resources to do tooling. So they do tooling around AI, using AI to do their analysis and some of their automation and so on. The other category is solution providers, system integrators who bring the systems together and try to provide a customized solution to solve a customer's problem. And the third category is the security product vendors who are building these capabilities into their security products. So, what does AI give us? Efficiency and productivity. It also helps us in doing data analysis and providing insights of huge amount of data that we spoke about. And because it's machine, it's not humans, there is accuracy and reduced error. There is no room for human errors, though we will talk about accuracy at a later point of time from the perspective of AI being able to be accurate. And improved decision making, again it's the machines, there are no humans involved. And so that would be very objective in and has a lot of data points to make a uh, informed decision. And other thing is 24 bar 7 availability. The scripts, the automation and the AI can run 24 bar 7, whereas human professionals will need more breaks. So overall, all the advantages that we have spoken about of AI, that we all know about AI, are also applicable in the security industry. But traditionally, security industry has not been very aggressive in investing in AI. There has been several efforts. There have been several amount of work that has been done. So, but it is in different stages. Some companies may be ahead of the curve and might be having a sophisticated solution, but on an average, use of AI in security has not been that prevalent. Now we'll do a bit more of deep dive. We have been hearing a lot about AI, about machine learning, about different algorithms and generative AI and so on. But how do they actually help? How do they actually work? And how can they actually solve the security problems? So use of machine learning. So machine learning, different models and algorithms are used to, one use is to classify the data. So we can classify the data as safe versus malicious. We can use the clustering algorithms to do the anomaly detection and based on the patterns. We can also use recommendations based on historical data. And we can also use generative AI or AI in general to create a lot of scenarios, the data and scenarios, attack paths and so on. And we can do a lot of predictive forecasting, not only about the possible threats, also our resource management. For example, if we can predict that we need to do an update or we need to patch, then we can also allocate our resources, human and computer resources, to do whatever remediation action or the mitigations that are required to um, solve that security threat. One other use of AI or machine learning algorithm basically is to do the user and entity behavior and analytics. How is it done? Using the analyze the user activity and system behavior to detect the suspicious actions. So we have a concept of supervised learning as well as unsupervised learning. So in this case, we take supervised learning approach and train the data. So in case of supervised learning, you train the data, you train the model, mentioning that this is legitimate behavior and this is based on that, the model can detect that this is an anomaly or this has deviated from the expected legitimate behavior. So flag it as probably malicious content, right? And also other technique is the anomaly detection using different algorithms that are techniques that are present, time series analysis and RNN and so on. So we spoke about initially about the machine learning, the different usage at a very high level, at a conceptual level. Then specific techniques to solve a specific problem. For example, how do we do user behavior analysis based on using the supervised learning. We'll also see how unsupervised we'll talk about predictive analysis. So again, predictive analysis is one other way of doing anomaly detection. So we can analyze the historical data and attack trends and predict the future threats. So again, some of the anomaly detection techniques also applied on top of it, like time series and RNN. And using this, you can flag unusual activity and patterns. Now we'll come to unsupervised learning. So in unsupervised learning, the model learns as a process of as processing the data in the long term. It recognizes the patterns and tries to figure out on its own what is expected and what is the baseline and what is the deviation. So one of the popular mechanism is LSTM, is a long short term memory. In this, for example, a very popular uh, use case or example provided is detecting a dog picture or a cat picture. So there is this actually analyzes the series of data, serial data. So there is a long term memory where uh, you would know, for example, if you know, if you're watching a movie, you know that this movie is about, somewhere you know from the long term memory, that this movie is about forest and about nature, sorry, this is about nature, science and nature. Then recent events that you saw that you saw a forest in the picture. Now you have you have a entity which looks like either dog or a wolf. Now your long term memory says that this is about nature and this is about animals, but your short term says that before that you've seen a forest. So based on this, now you identify that the chances or the probability of this being wolf is higher because this is not a street. If it was a street, probably your term memory said it was a street, you would have assumed this was a dog. But since this was a forest, you did it. This is a very simplified explanation of how LSTM works. Similarly, in case of analyzing network traffic as well as the logs and data, we can look at the long term memory where we could identify an entity or a user as someone who has frequently um, has had access violation or has done behavior which is a deviation. And now in your short term memory you see sudden spike in traffic. So the probability of this being a attack or being a malicious activity is higher because in your long term memory you know that this entity or this activity has been a bit malicious, or has been suspicious. I wouldn't use the word malicious, suspicious. And now the current trend or current behavior, the short term memory shows that there has been some anomaly, some deviation from the normal activity, and you figure out that probably this is more malicious and you need to take the rank you provide or the prediction that you have, probability of this being a malicious attack is higher. So this is how LSTM, a very simplistic explanation of how LSTM works for anomaly detection, especially in the network traffic analysis and log analysis and data analysis. Also, another popular model technique that is used for threat detection is autoencoders. So we use unsupervised learning again here, and it identifies unsupervised learning identifies a pattern of data that can be again pre-labeled as good or bad traffic, or what is expected and what is a deviation. So based on its own learning over the period of time. Now, autoencoders try to reconstruct the input data. So, when they reconstruct, if there is a deviation from what is learned from unsupervised learning as a good traffic or expected behavior, then there is a deviation, and then you flag this. So, examples again, you can identify denial of service attacks, a sudden spike in the traffic volume, and port scan, repeated attempts to connect to unusual ports. If you see that as a anomaly there, data exfiltration, large data transfers outside normal business hour because it's a deviation from expected at a 12 a.m. or 1 a.m. Time frame. If a huge data transfer happens, then that's not the normal time, and this is again a anomaly or a deviation from expected behavior. So we learned about various different AI and machine learning techniques that could be used. So what we are trying to understand is that how these algorithms are applied in the context of cybersecurity to do threat detection and to help us to proactively uh, protect our infrastructure. uh, Gen AI, generative AI, in the recent past has been quite popular and has been adopted. So that's a very great progress. It's been quite helpful. It's solving a lot of problems. Now, how can we use it in threat detection and analysis? So it helps in creating a realistic variation of malware and trying to do adversarial samples. For example, there is a concept of generative adversarial networks, GANs, and they use the techniques of creating something similar and comparing. So, creating these samples for testing and for simulating attacks can be done via Gen AI. Again, as we said, simulation of attack, where we can try to do hacking of a system, or red team can actually try to simulate attack scenario and see how well prepared our infrastructure and security team to address real world threat and attack. Also, Gen AI could be used in security automation and efficiency. So, generating security reports, Gen AI can help there. And also, automatic threat hunting, specifically searching for using right prompts. You can search for indicators of compromise, IOCs, in a large amount of data which humanly is not possible, or maybe simple search queries in traditional tools are not sufficient. So Gen AI can help in this, in getting very optimized search and queries to do the threat hunting. Also, uh, while Gen AI could, or AI can help in helps the attackers to attack more efficiently, we can also use it for countermeasures. So generating deceptive content and trying to um, engage with attackers, and trying to find out their tactics, especially in the research scenario and so on. Creating these contents can be done via Gen AI. Also, content generation for security awareness, for doing your training and so on. So, the way I look at AI, again, to the as I explained earlier, that there was three categories of usage. One is the advanced tooling, and other is solutions which are customized, and the third one is having AI features within the product. So as a security professional, how can you leverage security Gen AI or AI is something that we'll talk as we progress. So one other AI use case or application is security automation, using the reinforcement learning. Basically, here reinforcement learning works on rewards. So when a right incident or right analysis is done, the agent is, or the automation is rewarded. So, learning from experience, the agent tries to maximize the rewards. So, by doing much more in depth analysis and getting better results every time. And then it continues to learn and continues to update. So, when I say automation, we are talking about automated agents in the security orchestration and security operations. So, this is again a relatively new idea, which is slowly gaining traction, and some of the products are building some of the basic AI capabilities into their products, and eventually the future might lead to automated agents who can do some of these activities of threat hunting, and also remediation actions, automated remediation. As I mentioned earlier, there are challenges in AI also. So, first of all, AI is not yet completely mature. Also, the data quality that the result of AI models depend on the data quality, and also achieving that data quality, cleaning of the data and data integration, getting the data from all your tools, your entire system, and integrating it and cleaning it is a difficult task. So that's one of the challenges. Privacy and trust and reliability, how do you collect the data, how do you store, is also a consideration. And the security of the AI itself, the models themselves, they could be attacked, so that also has to be taken care. And lack of expertise, uh, the security team, security professionals probably may not have enough AI expertise to understand the challenges or and understand the sophisticated attack powered by AI, as well as to provide solutions which are AI centric. And also we have a lot of any every organization has a lot of legacy systems, and how do you bring in these new technologies into the legacy systems. So I'll quickly go to what does the future look like. So we spoke about various methods, various models, various techniques which can be used. So this is not a exhaustive list, but some of the applications where we have been using AI in some form or the other. What you can see is more adoption and continuous evolution, and these models maturing and using more and more AI to be and having better, accurate solutions and much more advanced solutions. So, theme one, future looks like AI will be integrated into every form of products and every interactions in some form or the other, and the models will get mature. So that's one prediction of future, how the future will look like. Not to say that we don't have it currently, there is it does exist. So but it would evolve, and more and more softwares, more and more tools will start using AI. Other aspect is the human AI collaboration. So how can security professionals can you use the Gen AI natural language for chatting, for summarizing, as we mentioned earlier, report generation, automation, threat hunting, proactive threat management, and so on. Now, I'll come to the important point. So, with the advent of every technology, there is a question, there is a fear. Will it make me relevant? Will it make my skill set relevant? What does this mean to a security professional? The will automated agents replace me? What will my job look like? This is similar to when the digitization, automation happened in the IT sector. Similarly, security also will go through the same cycle. So, AI will the advent of AI will need the security professionals to update their skill sets. So, data analysis and programming using AI frameworks, etc., would be required. While in the past, probably a simple scripting was done, now probably you'll have to leverage the AI frameworks that are available. And understanding the AI threats also is how the AI uh, can be used for attack, and the threats in AI also is required. And Gen AI techniques, mainly some of the products already have Gen AI as part of uh, their security products. So to be able to use those chats and Gen AI features in those products, understanding the Gen AI techniques, prompt engineering, data preparation, all of this is required. And how one of the probably more advanced topic would be how to do security automation using Gen AI. So the takeaway here is AI is a tool, so it won't replace humans, but the way we would do our work, the way a security professional will do their work will change. So they will still play a crucial role. Probably they would be defining the model, they would be taking the help of the AI agent, AI models to do their job. So in my mind, this is just a technology, this is just a tool. So people who ride this wave, learn the new technology, and learn how to use this technologies to get better results and be more effective in their job, would go a long way in this professional. With that, we have reached the end of the session. So I'll come back and see if there are any questions. And uh, we have questions. Moderator, could you please help me to get the questions onto the screen, or let the uh, person who has the question to ask this question? So if you have a question, you can also have this in the session chat. Let me try to address one or two questions before we wrap up. Waiting for, I think there were a few questions there. So just looking at the technicalities of how to get them to ask their questions. While moderator tries to get them on the chat or on the screen, probably I can just talk about a bit more on how prevalent the AI is, how the AI solution is working in the current set of products. Okay, I have a question. Can you talk about approaches taken in one reproduce DDoS attacks, and cause they can cause very different. They can be very different and automate mitigations. Sure. So again, what AI brings to the picture is that it can automate, it can generate data, it can do analysis much faster and much efficiently than your traditional business logic, traditional scripts that you write, traditional data generation that you provide. So simulation using Gen AI or simulation using AI can actually, for example, AI can go and repetitively go and start pinging a port and start sending requests. So this request generation, for example, one of the use cases Gen AI is helping in software field is code generation, right? So code generation to do a particular task. So instead of writing your own script and trying to figure out things, you can just ask the Gen AI to write a script to simulate a port ping or sending requests to a particular socket or a particular server on a particular port and so on. So this is how you can leverage Gen AI to write these scripts and generate these code which can actually run. And that's one use of Gen AI. And analysis of this data again, once you, because there would be like thousands of devices, thousands of servers, and thousands of iterations that you need to do, which analysis of that data manually would or using the traditional techniques would be more time consuming, whereas AI can help in in data analysis and coming up with some predictions much accurately and much better way. So that's how you can leverage AI in simulating a DDoS attack. So thank you all. It has been a great experience talking to you all. I think my LinkedIn profile is shared, so feel free to connect with me and ask any questions if you have. And looking forward to having a chat with all of you. With this, we'll wrap up today's session. Thank you all for attending. It was really nice. Thank you, and wishing you all the best.